Hello my friends and fellow MonoGame developers, my name is Chris Whitley, also known as Aristotle Dev in the MonoGame community, and today in this video we're going to be discussing how to achieve independent screen resolution rendering using a scaling matrix as opposed to the traditional trick of using a render target 2D. Using the render target 2D trick is something I discussed in my previous video. There should be some thing popping up on the screen right about now to link to that if you want to go look at that. However, in this video, we're going to talk about how to achieve that same goal only using a scaling matrix that gets applied to our render instead. So just to go over again what independent screen resolution rendering means, it means that we have, as the developer of the game, we have an idea of the resolution we want our game to be. This is typical in pixel art games when you have like low resolution pixel art games that are something like 640 by 360 or something super low. But obviously players can't play the game on a window that's that tiny. It would be really hard to do. So the window needs to be able to scale up. But when the window scales up, we want our actual game that's being rendered to still be rendered at our ideal resolution of 640 by 360 or whatever that pixel perfect resolution is for your game. So how do we achieve having the window for the game scale up and down, but maintain that same aspect ratio of what we want our game to be rendered at internally? And that is what independent screen resolution rendering ultimately is. So with that, I guess, definition and explanation out of the way, let's just jump right into doing this. So right here in front of me, I have a MonoGame project that's been created. It's a brand new MonoGame desktop GL or MonoGame cross-platform desktop GL project. Nothing's been changed since it's been created. It's just the standard project, with the exception that I've already added a piece of content to it to run through the content manager, which is just this image. This image is just a preview image from Kenny's website for his 2D platformer kit. If you're not familiar with Kenny, fantastic website. Definitely go check it out. He has amazing free assets that you can use to help kickstart and develop your games. I'll leave a link in the description below to Kenny's website if you want to go check that out. But for now, we're just going to use this image to represent what our game screen might look like if we were making a platformer game and we wanted to keep it, use that independent scaling resolution for our game. So we're just going to use this image. So I guess the first thing to do would be to actually take that image and draw it in the game, right? So let's create a texture 2D. And we're just going to call it image, and then we're going to load it in just like we would any normal way. Content.load, texture 2D, and platformer is the name of that file, right? Platformer, yes. And then we're going to come down to our SpriteBatch here, or not SpriteBatch, but our draw. We're going to take our SpriteBatch, we're going to begin, and because we're doing pixel arty type stuff, we're going to set our sampler state to point clamp to keep it nice and pixely. Always remember to end your SpriteBatch. And then between that, we're just going to draw our image. So draw image, we're going to draw it at 0, 0 top left corner with a color tint of white, so that there's no color masking or color tinting applied. And if we run this now, we should get a MonoGame window with that image drawn to represent what our game screen might look like. And there we go. We have it. But there's a problem here for our sample. The problem is the game window itself is smaller than the actual size of our image. So let's fix that problem first. And that's actually going to factor into the whole thing we're doing. So if we think about it, this image that we're using kind of represents our ideal resolution for our game, right? Whatever that resolution may be for your game. So let's determine what the resolution of this image is. So I'm going to right click the image and go to open containing folder. There it is, right click, properties, details. And this image is 918 by 515 pixels. So 918 by 515. So let's use that value as what our ideal resolution for our game would be. So we'll create two integer values. Resolution width is 918 pixels. And private integer resolution height is 515 pixels. And then let's go ahead and set our graphics preferred back buffer width to our resolution width. And we'll do the same thing for the height. Preferred back buffer height equals resolution height. Remember to apply the changes. There we go. Now if we run the game, we should get a window that's 918 by 515 and fits our entire, what's representing our game from this image within the window. And we do. There we go. Cool. Now, let's introduce the problem that we're trying to solve. All right. So the problem is, you want the user to be able to resize the window. So you add that pesky line of code in here that says window allow user resizing equals true. And when you add that in and the user runs your game, they now have a window with a maximize button, and we get all this cornflower blue background because our actual game render isn't scaling to the size of our window. Or the user might use the scaling handles to do something like this. So now we have a problem. What we're rendering as our game isn't scaling to the window, but we need it to, but we also want it to maintain that aspect ratio of our original intended resolution, which in this case is 918 by 515. So how can we do that? Using a matrix. Well, the first thing we're going to need to do is create a matrix that we can use to do this with. So let's create a matrix. We're going to call this matrix. And we're just going to call this, I don't know, screen scale matrix. That's what we're going to call it, screen scale matrix. You can call it whatever you want. I'm going to call it screen scale matrix. And we need something that's going to create the value for this matrix. So let's just come down here at the bottom, and we're going to add a new method, private void update screen scale matrix. And just to start out, let's do screen scale matrix equals matrix dot create scale 1.0. 1.0. It does nothing. It literally scales it and does nothing. But this is our starting point. This is where we're starting. Okay. So we have our screen scale matrix that's being created inside this method. Now, where do we apply that matrix? How do we use that matrix? Well, that's done inside the SpriteBatch.Begin. One of the parameters inside SpriteBatch.Begin is a transformation matrix that we can supply. You can see it right here. So let's do transformation matrix and give it our screen scale matrix. So now that we have our matrix set as our transformation matrix, let's run the game and see what happens. Any guesses before it pops up? I bet you weren't guessing that we would just get a blank window. So why are we getting a blank window? We're getting a blank window because even though we are giving it a matrix and we have a method called update screen scale matrix, that method's never being called. So the value for that matrix is never being set. So it has a default value, which is matrix identity, which basically is going to give a scale of 0. Not good. So in our initialize method, we can just call update screen scale matrix and hit run. And now, any guesses? You were right. Now it renders our game at a scale of 1. And we can show that this scale matrix is actually scaling the game by coming down to our scale matrix and saying, let's do it at a scale of 2. Okay, let's see what a scale of 2 is. Let's experiment a little bit, change some numbers to see what happens. So if we do it at 2, now our game is rendering at 2 times the size. However, you will notice that even though it's rendering at 2 times the scale, it's scaled from the top left corner, like it's scaled like this instead of scaling from the center, right? But we'll fix that in a little bit. Don't you worry, that will be fixed. So for now, we have a scale matrix. Now we need to determine how do we calculate what that scale should be. How do we go from the size of the window or the size of the back buffer with our intended resolution and perform some calculation that's going to create this value for what the scale should be in order to maintain that independent resolution rendering that we want for our game. And that's where all of the magic is going to start happening. So to start with, let's first determine what the size of our screen, our back buffer that we're drawing to. Let's determine what the size of that actually is. So we're going to create 2 variables. We're going to call it screen width, and the width we're going to do graphics device, that presentation parameters, that back buffer width. And then we're going to get the screen height. It's going to be graphics device, that presentation parameters, that back buffer height. And so from this, we can determine the size of the actual screen. We'll say that. We're determining, we're getting the size of the actual screen, the width and height of the actual screen. Cool, but that does not give us the information we need in order to scale. The next thing we need to do, and this is sort of something we did in the previous video with the render target 2D, is we need to determine basically how much we're going to scale this, right? Because the window may be taller than it is wide. Actually, let me show what I mean by this. Where's my pen? There it is. So the window might actually be taller than it is wide, or it might be wider than it is tall. So we need to figure out how we're going to take our game resolution that we're rendering and fit it inside the box of what is the actual window being rendered, essentially. So let's delete that. There we go. So to do that, we're going to create a little branch right here. Well, before we create a branch, we need to create something called a virtual resolution. So private integer virtual width equals, and we'll keep it at the start, we'll keep it the same as our resolution width and resolution height. Private integer virtual height equals 15. So the difference between these two is going to be the resolution width and height. This is the desired resolution of our game. The virtual width and height, this is going to be the resolution we render the game at. So the resolution with the height is our static, it's our what we want the game resolution to be. The virtual will change depending on the size of the screen. We're basically going to be creating a virtual box that fits inside the window, essentially. And so because we know the resolution, our actual resolution is set in stone, never going to change, we can mark these as read only. These aren't going to change. They're always going to stay the same. So now that we have that, we need to take the screen width and the screen height that we have, and we need to calculate what our virtual resolution should now be based off the size of the screen. So to do that, we're going to do an if statement, and we're going to say if the screen width, the width of the actual screen as it is right now, divided by the resolution width, the actual width we want to render at, is greater than the screen height divided by our actual resolution height. So this is basically saying we're taking the aspect, or we're taking the ratio of the actual width versus what we want our width to be, and checking it against the ratio of the actual height with the height that we want it to be. And in this case, if the width is greater than the height, right, we're going to need to calculate a virtual width and a virtual height that's going to make it so that we fit things width-wise into the screen, but the height may not fill all the way, and I'll explain that in a second. But we need to match, since the game window is wider than it is tall, we need to match the width. So we're going to create an aspect, and the aspect for this particular scenario is going to be our screen height divided by our resolution height. So that's our aspect in this situation. And then using that aspect, what we can do for the actual virtual width is we can set the virtual width equal to our aspect times the resolution width. Resolution width. There we go. But that does need to be a integer value, so we'll just do that. And so what we're doing is we're taking the full resolution width of our game and we're multiplying it by this aspect ratio that we've calculated to ensure that it fits inside. And then for the height, the actual height in this case, we're just going to set it to the actual screen height. We'll make that in it. Now, on the flip side, if our screen is taller than it is wide, we need to do sort of the same thing, but swap what we're doing with the virtual width and the virtual height. Those need to be swapped. So we'll say float aspect equals, and in this case, the aspect is going to be the screen width divided by our resolution width. And then we'll say virtual width. Our virtual width is just going to be the screen width. And our virtual height is going to be the one that gets calculated now. So virtual height equals the aspect that we have times our resolution height. So cool. Now that we've done this calculation, this calculates what our virtual width should be. Calculate the virtual resolution based on the current screen width and height compared to our intended resolution width and height. Awesome. So we have this fantastic information now that gives us our virtual width and our virtual height. So how do we now go from having a virtual width and a virtual height and using that to create a scaling factor? Well, super simple. We're going to take our virtual resolution, or yeah, virtual resolution width, and we're going to divide it. We need this to be in float values. We're going to divide it by our actual resolution width. So we're gonna get an aspect of what our virtual and our resolution is. So if we run this now, things are rendering properly. That's fantastic. So what happens when we scale the size of the screen? We still have a problem. Can anyone guess what the problem is? I'll give you a couple of seconds to guess. See if you can guess what the problem is. 3, 2, 1. Yep, that is correct. We will need to update this scaling matrix anytime the size of the window changes. Right now, we're not updating it when the window size changes. And because we're not updating it when the window size changes, it's only ever getting set once. So how do we do that? Well, there is a window client size changed event that we hook into. So on client size changed. And then we'll just create the method signature for on client side changed. You can just use the like show potential fixes, generate the method if you want to, which I guess we'll do that just for simplicity of the video. But this is the signature for it. It needs a sender object and an event arg for the parameters. And then in here, we're going to say if the window, hold on, window client bounds .width is greater than 0, and the window client bounds height is greater than 0, because we don't want to do this if someone shrinks the window all the way down to 0, right? We don't want this to run. Don't do that. So first we check if the width and the height of the window are greater than 0. And if they are, we then do our update screen scale matrix. But one other little trick we're going to do here is when you're resizing a window, this event is going to get called. So if I click on the window and I drag it a little bit, but I don't let go of the mouse button, right? If I click the window and drag it a little bit, that event gets called. And if I keep dragging, it gets called. And if I keep dragging, it gets called, so on and so forth. So we don't want this like constantly kicking off, right? We don't want this just to constantly be running. We want it to kind of have some way in there of telling it to only run when it needs to run. So what we're going to do is we're going to create a flag, private bool is resizing. And in our on client size changed, we're going to add an additional check to say if not is resizing and the window width is greater than 0 and the window height is greater than 0. Then is resizing equals true, flag that we're resizing. And then after we've finished with our matrix updating, we'll say is resizing is false. Now, if we run it, we have our game window. Sorry about that. We have our game window. And if I resize it, let's do it this way. You can see it's scaling with the window. But now we have another problem. The problem we have is the one we talked about originally. It's scaling from the top left corner. So we are still getting these awkward situations where it's determined that the correct width, height, aspect ratio, whatever you want to call it, is within these bounds, but we're getting this awkward part at the bottom here or on the sides here. So how do we fix that? Well, that's a fun fix. What we can do is we can provide our own viewport that we're going to give to the graphics device. So do private viewport, and then in our update screen scale matrix resolution, screen scale matrix method, after we've created the screen scale matrix, we say viewport equals new viewport, and we need to set the x value and the y value need to be set so that they are centered on the screen, essentially. So to do that, they have to be in values. We'll do the screen width divided by 2 minus what our new virtual width is divided by 2. Same thing for the y. We'll do integer screen height divided by 2 minus our virtual height divided by 2. Then for the viewport, our actual width is going to be our virtual width, and our height is going to be our virtual height. And then we set our typical min depth equals 0, max depth equals 1, call it a day. So we've created the viewport here. Now when we draw, we need to tell our graphics device okay, sorry, I'm confusing something with my other library. We need to tell our graphics device viewport to be equal to that viewport that we've created specifically for this scenario. So let's run this. The game opens. We get our 918 by 515 resolution window, just like we have set by default. The user comes in and they say, you know what, this screen is too small. I'd like the screen to be a little bit bigger. So they grab this corner handle, they resize, boom. Now the screen is bigger, and because we created that viewport, the viewport is centering what we're drawing basically to the screen. We now have this nice letterboxing effect at the top. And just to just show that a little bit easier, let's change the cornflower blue to black. Because typically when you think about letterboxing and pillarboxing, you think about black bars, right? You don't think about blue bars. So let's change that to black. There we go. So let's stretch our screen out, and there's our pillar boxing on the left and right with our game screen centered. So this is the largest it can scale the game window up within this window size in order to maintain our actual resolutions aspect ratio of 918 by 515. If we make it a little bit larger, there we go. I did not intend for that. There's actually a little bit of pillar boxing on the side. You might not be able to see it. I didn't intend for that to be almost perfect. But now if we scale out, not scale outwards, sorry. If we scale upward, like that, we now get the game centered, but we have the letterboxing on the top and bottom, like you would normally get. And if we maximize the game window at a maximum resolution for my screen, it creates a screen like this with the pillar boxing on the sides. So here we have achieved independent screen resolution rendering using matrices, or not matrices, a singular scale matrix, along with a viewport. But this is a method of doing it and avoiding having to use render targets and scaling the render targets up if you'd like to go this route as well. So just to kind of like briefly, quickly go over everything we did here. We defined a desired resolution of our game. And this is the desired resolution you want your game rendered at. So natively your game might be 640 by 360 or 360 by 180, whatever those small pixel resolutions are that people use. So that's your desired resolution of your game. And then we have a virtual width and height, which is this virtual resolution that's going to be calculated to fit inside of our game window based off of what our actual resolution that we want to be is. Then we have a matrix, screen scale matrix, and a viewport that we're going to use. The viewport is used to center it to the screen. We have a method called update scale matrix, and what it does is we pull out the actual width and height of the screen, and then based on the width and height of the screen with our intended width and with our intended resolution width and intended resolution height, we check, is it wider than it is tall or taller than it is wide? And based off of those two values, we calculate what our virtual size is going to be. So does it need to be tall? Does it need to be wider than it is tall, taller than it is wide, etc. And then from that, now that we have an actual virtual size, we can take our screen scale matrix and we can actually create the scale matrix based on an aspect ratio of our virtual width with our intended width. So that gives us our matrix. And then after we create the matrix, we create the viewport, which is the only thing special about the viewport is the X and Y. I use the actual screen width and the virtual width, screen height, and the virtual height in order to center what we're drawing to the screen. And then it sets the actual width and height to those virtual widths and heights that we calculated. So this happens in our update scale matrix method. And then we have to have something that's going to trigger that whenever the screen resizes. So we do that by using the window client size changed event. When that event kicks off, as long as the window itself is greater than 0 on the width and the height, then we kick that off, we update the scale matrix, we recalculate it, and then when we actually draw, we set the viewport of our graphics device to that scaled viewport, and then we pass in our scale matrix as the transfer matrix for our game. Now, at this point, some of you may be wondering, all right, cool, we're passing in a scale matrix, but I'm using a 2D camera in my game. And my 2D camera already provides me with a matrix to pass for the transformation matrix. And that's fine. If you are using a 2D camera with a matrix in your game, what you can do for the transformation matrix is first in here, you would do whatever your camera matrix is. So camera, you might have like camera matrix, whatever your camera matrix is, and then multiply that by the scale matrix. Doing that will still give you the functionality of your 2D camera along with the independent screen resolution rendering provided by the scale matrix. So, wow, that was a lot. I hope this video explains this concept in a way that was understandable. If you have any questions about this or any comments on this video, please let me know below. And just a reminder, if you would like to support this channel and more tutorial content like this for MonoGame, I do have a Patreon. You can find the link for the Patreon in the description of this video below. There's also the MonoGame Discord, which I always like to represent. The link for the Discord will be in the description below as well. Come by, say hi, meet other MonoGame developers, show off the work you've been doing, ask questions, hang out with us. We're cool people. I think we're cool people. Other than that, I hope you're all having a wonderful day, evening, night, morning, whatever time of day it is for you, wherever you're at. I hope it's wonderful for you right now. And with that, I am out. Take care.